So in this video we're going to look at using the square root property to solve a quadratic equation. And the square root property is going to pertain to a very specific case where the linear term is not showing up in the expression. So in this case, notice that we have a standard form of a quadratic, ax squared plus bx plus c equaling 0. Notice that what we have over here, there's no x to the first power term, so the bx term is missing. So what we're looking at is a solution technique that applies specifically to the case when b is equal to 0. It applies in other instances as well, but this is a case that it is very specifically intended to deal with. And the square root property is really simple. It says, hey, if you have some algebraic expression that's being squared and it's equal to k, that there's going to be one of two possible answers. We either get the square root of k as an answer or the opposite of the square root of k as an answer. And we usually write it in a compacted plus or minus the square root of k type of a form. So let's take a look at this in practice. So here I have x squared minus 4 equals 0. And what I want to recognize is that the linear term, the x to the first term, is missing, which means if I add 4 to both sides, I'm in a position where I have something squared equaling k. In this case, I have little x squared equals 4. And if I do this wrong, which I'm going to do, what I'll notice is I lose a solution. So let's say to get rid of the squaring, I take the square root of both sides. And I say, hey, the square root cancels the squaring, leaving me with an x, and the square root of 4 by definition is the positive square root, so it's just 2. By definition, the square root of 4 is positive 2. And what we want to remember, this statement right here, x squared equals 4, is saying find all x such that when you multiply them by themselves, you get a 4. And certainly 2 satisfies that condition because 2 times 2 equals 4. But what we want to notice is that the opposite of 2 times the opposite of 2 also generates a 4. So by not including the plus or minus, we lose half the solutions to the problem. So the way that we do this correctly, we start with the original. We notice the linear term is missing. We add the 4 to both sides. We then take the square root of both sides. I'll leave myself a little room here. We take the square root of both sides. But the instant that we take the square root of both sides, we address the fact that we're going to get two possible solutions to the problem. One will be the square root of 4, and the other will be the opposite of the square root of 4. So the square root cancels the squaring, and we get plus or minus the square root of 4 is 2. These are the two numbers that, when squared, give you a 4. If we wanted to write the answer in set notation, we would just say x is an element of the set that contains negative 2 and 2. Although for my purposes, unless I explicitly tell you to put it in a set notation, this compacted notation is just fine. So looking at another example, use the square root property to solve x squared minus 12 equals 0. X squared minus 12 equals 0. So what I want to notice is that the linear term bx is missing, which means I can add 12 to both sides. And then to get rid of the squaring on the x, I'm going to take the square root of both sides. The instant that I do it, I put the plus or minus. If I wait and do it later, I get marked down. So I get my x equals plus or minus, and now I want to recognize that 12, the square root of 12, is not in simplified radical form because 12 can be decomposed into 4 times 3, and 4 is a perfect square. So I get plus or minus, the square root of 4 is 2, and the square root of 3 is already in simplified radical form. So there's my two solutions. If I wrote it in set notation, I would say x is an element of the set that contains negative 2 square root of 3, comma, 2 square root of 3. So one more example. So here I have x plus 2 quantity squared equaling 1. And what I want to do when I have a situation like this, where I have an algebraic expression squared, and on the previous screen, that's why a capital X is sitting here, because it doesn't have to be the variable little x, it can be an expression that's being squared. And in this particular case, we have an entire expression, x plus 2, that's being squared. And we want to avoid the temptation to just square this out. Ooh, I'm going to get x squared plus 4x's plus 2 plus 4, sorry. And then I'm going to subtract 1 from both sides and start grinding along. We want to avoid just expanding the binomial if we don't need to. What I want to recognize right here is I'm already in a position to be able to take the square root of the term that's being squared, which means I'm going to go square root of both sides, but immediately I put plus or minus. So here I get my plus or minus 1, and the squaring the square root cancels the squaring, dropping out the x plus 2. And now I can subtract this 2 from both sides, so I get x equals plus or minus 1 plus 2. And this is going to generate, I left off my 1, plus or minus 1 plus the minus a 2. This is horrible. Subtract 2 from both sides, plus or minus 1 minus 2, because we need to subtract 2 from both sides. And this is going to generate two answers. Positive 1 minus 2 is negative 1, and negative 1 minus 2 is negative 3. So we generate two solutions. And if I'm going to put it in set notation, I'm usually going to put the smaller of the two numbers first and the larger number second.